Hi, Evergreen. Let's do Chapter 7, Lesson 3. More about parallelograms. And so let's remember what the properties of a parallelogram are. The opposite sides are parallel. The opposite sides are congruent in their length. The opposite angles are equal to each other. And any two adjacent angles add to 180. So let's look at that. XW is parallel and congruent to YZ. XY is congruent and parallel to WZ. And then when it says the opposite angles are congruent, it's meaning these right here. So X and Z, Y and W. And any adjacent angles add to 180. So Y and X add to 180. X and W add to 180. And W and Z add to 180. And Z and Y add to 180. Here are a picture of each of those attributes again, except we're going to add the bisects. So the diagonal bisect, here we go from corner to corner and corner to corner. They exactly hit midpoint and they are equal. Theorem 27. A quadrilateral is a parallelogram if its opposite sides are equal. And a quadrilateral is a parallelogram if its opposite sides are equal. So not only are they, oops, what is the difference between these two? Oh, opposite angles and opposite sides. So the opposite sides are equal and the opposite angles are equal. Okay, and so now a quadrilateral is a parallelogram if two opposite sides are both parallel and equal. So the sides have to be parallel and equal, just like we talked about earlier. And then a quadrilateral is a parallelogram if its diagonals bisect each other perfectly in half. So let's look at this. It says 2x plus 2y equals 360. Why is this true? Well, we know that 4 interior angles add to 360 of a quadrilateral, and so therefore that is why the sum of the angles in a quadrilateral is 360 degrees. X plus y equals 180 degrees. Why? Well, division. We take half of the angles, and so therefore it would be half 180 degrees. Angle A and angle B are supplementary. That means they add to 180. And angle A and angle D are supplementary. Why? Well, the angles are supplementary if their sum is 180 degrees. Number 8, AD is parallel to BC. AB is parallel to DC. And so the opposite sides are parallel. The supplementary interior angles on the same side of a transversal mean the lines are parallel. And so if we think of these as parallel lines, AD and BC, and this is a transversal, we would see that this X and X are equal. And therefore, they'd also be on the same side. They'd be a linear pair. ABCD is a parallelogram. Why? Because a quadrilateral is a parallelogram if the opposite sides are parallel. Okay, let's look at this. If we draw this line going from D to B, do you see how it bisects this quadrilateral? And it makes two even angles, 1 and 2. So, 2 points determine a line. Because AB and DC are parallel, and we know that by these little red triangles showing that these lines are parallel, and these dashes show that they are equal in length, then we know that angle 1 and angle 2 are congruent. And why do we know this? Well, we know this because parallel lines form equal alternate interior angles. See how these are alternating, and they are interior because they're inside of these two parallel lines. If we think of these as our parallel lines, DC and AB, and this is our transversal, BD, then these would be interior because they are inside our parallel lines, and they're alternate because they're on opposite sides of the transversal. So we're using our lesson from previous lessons as a proof in this one. DB equals DB. Anytime you see DB equaling the same thing on both sides of the equal sign, it's like a reflection, and it's called the reflexive property or the reflexive rule. Because we also know that AB equals DC, so AB equals DC and their length, we talked about that earlier, we know that triangle ABD, right? And CBD are congruent. And how do we know this? Well, let's talk about the things that we know. We know that they have a side in common, the bottom and the bottom. We know that they have this length in common that is also congruent. And we know that they share a congruent angle, 1 and 2. So we know side, angle, side. 14, AD equals CB. So now we're talking about these left and right sides of our parallelogram. How do we know that they are equal? Well, we know that these triangles are congruent, and so therefore the corresponding parts of congruent triangles are congruent and equal. So we know that this one, this angle, and this line is congruent, and so therefore we also know that all of these angles and all the sides of these two triangles are equal, and AD and BC are, when we're looking at this, the lengths and sides of triangles within this parallelogram. Therefore, ABCD is a parallelogram. Why? Well, we know that a quadrilateral is a parallelogram if its opposite sides are equal. So not only do we know that AB and DC are equal, now we've proven that AD and BC are also equal. And so therefore we have two opposite sides that are equal. These are parallelograms. Let's look at this parallelogram. Now it's bisected, and it makes two angles, 1 and 2, on either side of the bisecting line, and then we also see that we have 3 and 4 that are equal. Okay? DC and AB are congruent, and we pretty much know that AD and BC are congruent. It wants to know, because AC and BD, we should say 1D there, bisect each other, AE equals EC, so let's look at that. Oh, there should be an E here. AE equals EC, and BE equals ED. So this midpoint is E. Why do we know this? Well, a line segment that is bisected is divided into two equal parts. Equal parts. Angle 1 is equal to angle 2. Why do we know this? Well, we know that DC is equal to AB. These equally cut A and C in half, creating two equal angles. And so therefore we almost have two triangles, don't we? We have 1, 2, 3. We have side, angle, side. And here we have side, I'll start down here, side, angle, side. We also know that the vertical angles are equal. So just like we've talked about thinking about these are parallel lines, and this is the transversal, we also know that these 1 and 2 are vertical angles. AEB and CED are congruent triangles, and why? Side, angle, side, like we talked about earlier. Number 19, AB equals CD, the top and bottom, and also angles 3 and 4 equal each other. Now, if we think about this as a parallel line, and this is a parallel line, and AC being our transversal, that would make 3 and 4 interior angles, and they are alternate interior angles, right? We also know that they are corresponding parts of congruent triangles. So we have triangles, and they are congruent parts. AB is parallel to CD. AB and CD. They are parallel. How do we know this? Well, they have equal alternate interior angles, and that means that the lines are parallel, like we talked about earlier. So ABCD is a parallelogram. Why? Well, a quadrilateral is a parallelogram if two opposite sides are both parallel. So AB is parallel to DC. AD is parallel to BC. You are so smart. We have used a lot of our previous skills in this lesson to prove that quadrilaterals are quadrilaterals and they're parallelograms. Okay, see you soon. Bye.